Greetings, math fans. All right, so this is day 8 notes, and basically our topic today is called bearing. So let's write that out here. These are bearings. Now, my first question to you is, what is a bearing? Now, I know some of you guys are going to say bearing like a ball bearing. Maybe you say bearings as you're like hunting for bears. All right, but really, when I say bearing, think of like direction. If you're trying to get your bearings, right? You're trying to figure out what direction you're going, or you're trying to, during the war, you're trying to sink a submarine, and so you're saying, okay, fire a torpedo at a bearing of 25 degrees, and then launch, and the ship gets sunk from the submarine, I guess. Okay. Anyway, that's a bearing. So bearing is really used in navigation. And there are two types of bearing. So two types of bearing notation. The first one is one that's used actually quite often. If I just said a 60-degree bearing, okay, basically it's measured clockwise. So hopefully you know how to read a clock and not just digital clocks. So clockwise, so you're basically going to the right. Okay, so measured clockwise from due north. Okay, so that's important, from due north. So basically due north is straight up. That's not a very good straight up. Let's do that one more time. So from straight up, and then it's clockwise. So this is a bearing, 60-degree bearing. Okay, really easy. And you could have, like this is 90-degree bearing. This is 100-degree bearing. 180-degree bearing. If I went this way, that would be 270-degree bearing. So it's 180. This is 90. I can even do this. I can say this bearing, this is 350-degree bearing. So it's almost going back to due north, but it's going clockwise. I can say, the biggest I can say is 359.9999999 degree bearing, and you go almost all the way around. Okay? So that is the first kind of bearing. And the second type of bearing is, so let me put, the second type is you start with a north-south line and use an acute angle to show direction east or west from this line. So what I mean by that is, again, the north-south line is an up and down. It's a vertical line, basically. So let me just show you the 4 different possibilities. If I said north 60 degrees east, so this is a north-south line, north being up, south being down, okay, and then I go from that point, I go 60 degrees east, and east is to the right. Think of the East Coast, right? If you go to the East Coast, you hang a right, you go out to New York. So this is north 60 degrees east. Okay, so we just say it's a 60-degree angle here. Oops, 60 degrees. Okay. If I said north 20 degrees west, again, here's my north line, but now I'm going to the left. I'm going west, going out to California. So that's 20 degrees. And then I can say south 40 degrees east. And again, you're drawing a north-south line, but now I'm going south first, and then I'm going east. So I'm going south, then I'm heading east. That would be 40 degrees. Okay, and then the last one, if I said south 30 degrees west, that means again I'm going south, but then I'm going west 30 degrees. So I'm going to the left 30 degrees. Okay? So that is basically the how you would describe it if I said, basically a north or south letter, an angle, and then an east or a west. And you can go either way. So you can see this is actually pretty important here. It's an acute angle. Okay, that angle is never going to get bigger than 90, because if it's bigger than 90, then you're going to start to go into its other. In other words, if I did this one right here and I said north 100 degrees east, well, that wouldn't really make sense, because then I'm actually heading this way, and that would actually fit into this category right here, the south 40 east. That's why it's always an acute angle. Okay? So a couple more things here, just to mention. As we already talked about, this is a north-south line, okay, which is basically a vertical line. And then this is an east-west line, which is basically a horizontal line. Okay, very, very important. These are perpendicular. Okay, east-west lines, north-south lines are automatically perpendicular. Okay, and the last thing is talking about parallel lines. Okay, if I have two lines that are parallel, which I symbolize that with little arrows on there, and I draw a transversal across here, okay, and then I talk about these angles right here. These are called alternate interior angles. So alternate interior angles, which you guys learned that in geometry. And what can you tell me about alternate interior angles? They are congruent when lines are parallel. Really, really important. Okay? And then the other two parallel lines, here's my transversal again. If I give you these two angles, so this angle and this angle, what are those called? These are called corresponding angles. And what can you tell me about those? Again, if the lines are parallel, they are congruent. Okay? So those are some really important things to know before we actually start our lesson with bearings. So I have lots of examples already typed out for you, so let's do them. Alright, so number one, it says the Titanic sailed 45 kilometers on a bearing. So as soon as you see the word bearing, I mean, you have to go crazy, because you have to draw a north-south line. If you don't draw a north-south line, then you might as well just drop this class, okay, because you have no idea what you're doing. Alright, don't drop. So as soon as you got to sound a siren, okay? Kids that are watching this, maybe you haven't heard it yet, but the kids in class are going to hear whoop, 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 whoop. Okay, it's a big deal. Bearing problems, whenever you see the word bearing, and I highlight this, you're going to make a crazy sound, because it's such an important word. So anyway, you always draw a north-south line off a bearing, or for a bearing, and it's 31 degrees. So here we go. There's 31 degrees. The key to all these problems, math fans, are pictures. If you don't draw the right picture, you're not going to get the problem right. So Titanic sailed 45 kilometers, and let's put 45 here, on a bearing of 31 degrees. Okay, and then it sailed on a bearing, oh, there it is, whoop, whoop, whoop. Okay, there's your bearing. It sails at a bearing of 121. So I'm going to draw another dotted line here. And right, do you guys agree to the right is 90, and 121 is about right here? So that angle is 121 degrees. And that's 30 kilometers. Then it says how far is he from the starting point. So you're looking for this distance right here, the red. All right, you're given some information here. What you need to do is you're going to use trig, you're going to use Pythagorean theorem, you got to have a right triangle though. That's key. You have to prove to me it's a right triangle. If you don't prove to me it's a right triangle and you just start working on it as it is a right triangle, I'm not going to give you full credit for it. Okay, so the deal is, if this is 31 degrees here, don't you guys agree that this is 31? Because what do you know about bearing? If those two bearing lines are exactly parallel, Okay, if they're not parallel, you couldn't do it, but bearing lines are parallel, so that's why I can say I marked those two angles. Those are actually congruent because those are alternate interior angles. So I can say this is 31 degrees inside here. All right, and then do you guys agree that the whole angle here, this whole bearing, is 180 degrees? So if I subtract 121, I get just this green one here. So 121 from 180, and that gives me 59 degrees. All right, and then what you can do, you can say, oh, well, 31 plus 59, that's 90 degrees. Oh, that's beautiful. So now I can mark this as a right angle here. And then my question is, okay, well, I've got the 45 and 30. What trig do I use to figure this out? And you guys really should tell me there's no trig here, Mr. Kerfus. You're just using the Pythagorean theorem. Because I have two sides. I basically, let me redraw this now. This is kind of what my picture looks like. I have my right angle, which I just proved. This is 45. This is 30. Looking for x. So Pythagorean theorem. Okay? So basically, x squared is equal to 45 squared plus 30 squared. Okay, so I get x is equal to 54.1, and don't forget your units, kilometers, so 54.1 kerfometers. Okay, really pretty easy, but you got to prove to me these are right triangles. All right, so let's keep going. Two submarines, the Abbott and the Costello, are on an east-west line. So that's actually really nice. An east-west line, I know I can draw a horizontal line. That's an east-west line. And I'm going to write this as the Abbott and the Costello. And they're 10 kilometers apart. Okay, the Abbott detects a ship, the Stooge, at a bearing. Whoop, 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 whoop. There it is, bearing. Okay, at a bearing of 72 degrees. So I'm going to draw a dotted line. Always do that when you see the word bearing. And here it is, 72 degrees. The Costello also detects the same ship on a bearing. Whoop, whoop, whoop. I'm going to highlight it. So here's the Costello. It detects something at a bearing. Oops. At a bearing of 342. Now remember, guys, this is going around here. This is 90, 180, 270, and 342 is way up here. So, and you also remember, this is the triangle chapter. So you're drawing triangles. If you don't get a triangle out of this, go back to the drawing board because something's wrong here. Okay? Anyway, this is 342 degrees. And it says find the distance from the Abbott to the Stooge. So here's our Stooge. So I'm looking for, we'll call it X. Could call it C, little c, but that's okay. We'll call it X. So usually most of the stuff that I'm going to give you guys, you're going to use. Okay? So what do I have here? Well, since this is an east-west line, and that's 72 degrees, I know this is a right angle here, math fans. Okay, I know it's a right angle. If that wasn't an east-west line, I cannot assume it. Like, actually going back, let's go back to this one here. Some people would look at this and go, oh, Mr. Kerfus, this is a right angle here. And I would say, no, it's not. This line that I drew here, there was nothing that said it was an east-west line. I mean, I just kind of it happened to draw kind of nicely, but you don't know that it's east-west line, so you cannot assume it's a right angle. Okay, but if I say it's an east-west line, I can assume it's a right angle, and I'm good to go. All right, so if that's 72 degrees, that means this angle right here, let's do that in a different color here. This angle right here is going to be 90 minus 72, which is 18 degrees. Okay, so 18 degrees. Pretty easy. Now we got to look on the other side, all right, because again, we don't really know what kind of triangle this is. And do you guys agree if this is 342, how do you figure out this angle right here? Well, what a lot of people would say is, Mr. Kerfus, you can say 360 minus 342 and get this angle, and I can subtract it because, again, this is a right angle here. I can subtract it from 90. I'm like, yeah, you can do that. And there's nothing wrong with it, but the more efficient way to do it is how about instead we do this. So again, we're trying to find this angle right here. And do you guys agree that, let me do it in gray, that this angle here, right, which is 270 degrees, I can say, well, 342 minus that big chunk there, that leaves me with the green part right here left. Okay, so that's what it is. It's 342 minus 270. That gives me 72 degrees. So this is 72 degrees. And then what you have is, if you add these up now, you add this angle up and this angle up, 18 plus 72 is 90. That proves that this is a 90-degree angle, because those two other angles add up to 90. It's got to be a 90-degree angle. So I'm just going to draw it separately now, so you can see, because we got a lot of stuff written down there. We have enough information now. We're good. So this is what's given now. This is a right triangle. This is 18 degrees. This is 72 degrees. Certainly not drawn to scale. And this is 10. And I'm asking you to find x. Okay, so what do? Well, if I use 72 degrees, it doesn't, sine is opposite over hypotenuse, so I can say sine of 72 degrees is opposite over hypotenuse, which is 10. Okay, cross multiply, x equals 10 sine of 72. So x comes out to be 9.5 kilometers. So 9.5 kilometers. Okay? Really not that bad. Not bad at all. Alright, let's keep going here. Weather observers Jennifer and Kevin are on a north-south line. So if they're on a north-south line, you draw a north-south line. And this is Jennifer and Kevin. It says, and they're 4 kilometers apart. So 4. Jennifer detects a twister at point C on a bearing of 151. So really, I need a dotted line kind of through this. And if this to the right is 90, this is about 151 going down this way. Okay? Kevin detects the same twister at a bearing. So again, you guys, I didn't go crazy, sorry. Whoop, whoop, whoop. Let's see, so bearing, and Kevin detects a bearing at 61 degrees. So again, here's the bearing line kind of built into the triangle, but here's 61 degrees here. Okay? And it's basically, it says, how far is the twister from Kevin? So here's your twister, and I'm looking for x. So this is actually really easy. This one's already inside the triangle, 61 degrees. That's pretty sweet. So this angle is just basically 180 minus 151, which is 29 degrees. So if that's 29 degrees, 29 plus 61 gives you 90. That means this angle here is 90. That's pretty sweet. So once again, if you want to, it's not a bad thought. This is not too complicated of one, but you can just draw your triangle like that. This is 90. This is 61 degrees. This is 29 degrees, and this is 4, and I'm looking for x. So which trig function are you going to use here? Well, let's use cosine. Let's do cosine of 61. I could have also done sine of 29, but cosine of 61 degrees equals adjacent. So adjacent is x over hypotenuse, 4. Cross multiply, I get x equals 4 cosine of 61 degrees. So x comes out to be 1.9 kilometers. So 1.9 kilometers. Okay? Not bad. Okay, number 4. A ship leaves its home port and sails on a bearing of north 28. So again, bearing, you're going to go crazy. Whoop, 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 whoop. There's your bearing. Okay? And it's north 28 east. So, so let's just draw a dotted line here. And if you notice this type of problem, it says a ship leaves port and sails on a bearing, another ship leaves a port at the same time, or the same port at the same time. So really, I've got 2 ships that are leaving, and I'm just going to put it in the middle of the bearing line because I'm going to use them. I'm going to have both of them set sail. Anyway, this one is north 28 degrees. So this is 28 degrees east. Okay. Another ship sets sail in a bearing of south 62. So remember south, and then you go 62 east. So this is 62 here. Okay. it says if the first ship set sail at 24 miles per hour and the next one is at 28 miles an hour, just think logically. If the distance between them, they want to find the distance between them. So let me kind of extend this out a little bit. This distance, we're going to call this x, between them. And I didn't give you necessarily the distance, but I gave you how many miles per hour. Well, think about it. If it's 24 miles per hour and you're traveling for 4 hours, you basically 24 times 4 hours. Okay, that gives you 96. So 96 miles. And the other one is 28 miles per hour times 4, and that gives you 112 miles. So those are the units we're going to actually use. All right, so anyway, this one's 96 and this one's 112. Well, we still haven't proven it's a right triangle, but this is actually really easy to prove it's a right triangle, because do you guys agree if this top part here is 28 and this bottom part here is 62, you just add them together. So 28 plus 62 is 90, and of course you're subtracting from the whole thing of 180. So 180 minus 90 gives you 90 degrees. So you know it's a right triangle. Okay. And what trig am I going to use to find x? I'm not going to use any trig at all. In fact, I can't use trig because I don't even know these two angles to use trig. What I'm going to do is I'm going to use Pythagorean theorem. Okay. So I'm going to say x squared equals 96 squared plus 112 squared. And I get... I solve that, I get x equals 147.5 kilometers. So 147.5 kilometers. Okay? That's not bad. Okay, let's look at number 5. The bearing from Taco Bell to Subway is north 42 degrees east. Okay, so this is actually a little bit of a tougher problem, but it's a really good problem. So the bearing from Taco Bell to Subway is north 42 east. So let's do that. Here's your bearing line, because remember I said let's get crazy. The bearing, and that's north 42 east. So we're going to do like this, and that's 42 degrees east. And it says the bearing, so this is Taco Bell, and this is Subway. Then it says the bearing from Subway to Chipotle. So let's draw another bearing line because I'm going crazy. Bearing line from Subway to Chipotle is south 48 east. So south 48 east. Okay, and then the bearing, so this is Chipotle right here, and then from Chipotle okay, so let me highlight this word again. The bearing from Chipotle to Taco Bell, so again the bearing is another bearing line. Okay, so that's why we got 3 bearing lines here, math fans. That's south 68 west. So basically south is south, right, going down, and 68 west, we got to connect these anyway. So that means this is 68 degrees. Not necessarily to scale. You try to draw it as best you can, and you don't always get it to scale, but that's just what it is. Okay? So we have all our angles here, a lot of stuff. If Taco Bell and Subway are 60 miles apart, so this is 60, I want to know how far Chipotle and Taco Bell are. So we're going to look for x. Okay? There's kind of a lot here. First of all, that line between Taco Bell and Chipotle is not an east-west line. I do not know that. You cannot assume that and say, oh, that angle by Taco Bell is a 90-degree angle. You cannot do that. It's very, very bad to do that. All right, so I'm going to look for alternate interior. I mean, that's really key here, and angles that are supplementary, etc. Well, right away I see this 42, and this is 42. Okay, because those are just like we had before. Those are alternate interior angles, being those the bearing lines are parallel. Okay, so truly what you have here is you have 42 and then 48. If I add those together, I get 90 degrees. Sweet! All right, so 42 plus 48 is 90. Okay, good. So now I know it's a right triangle. That still doesn't give you enough information. I need to figure out, I have one side, and I know it's a right triangle. I need to figure out some more information. Well, what can we do here? you're definitely going to probably use most of the stuff that's given. So there are definitely a lot of ways to solve these problems, because I've had people tell me different ways, and I'm like, oh, that's good. What I would do is I would say, well, gee, there's a 48 right there. Well, kind of like just what I did before. If that's 48, isn't this 48? So if this angle is 48 and this angle is 68 and this whole thing right here is 180, can't I just say 180 minus 48 minus 68? And that gives me, basically that gives me this angle right here, which is what I want. I want one angle of the triangle. So 68 and 48 give me 116. So 116 from 180 gives me 64 degrees. That's what that angle is, 64. So if I redraw this triangle now I have enough information. If I redraw it, this is a right angle. This is 64 degrees. And I'm looking for X, and this is 60 miles, and it's beautiful now, man. Okay, because what am I going to use here? Well, I have opposite and I have hypotenuse, so I'm going to use sine here, right? So sine of 64 degrees equals opposite 60 over x. Okay, I cross multiply, so I get x sine of 64 equals 60 divided by sine of 64. And I get x is equal to 66.8 miles. So 66.8 miles. Okay? Just take some time. Just takes time. Okay, math fans, this is our last example. And this is actually a really good example. In fact, it's such a good example that you will see this example in your homework tonight. You will see it in your homework the next night. You will see it on the quiz, and you will see it on the test. All right? You need to learn how to do this type of problem. If you don't learn how to do this problem, then you're going to get it wrong on the homework, and you're going to get it wrong on the homework the next day. You're going to get it wrong on the quiz, and you're going to get it wrong on the test. If you choose to learn it right away, then you'll be good to go. Okay? So it's your call what you want to do, but I'm telling you, I'm a nice guy, and I'm telling you this is on the quiz and the test and the homework. So make sure you know how to do it. All right, so let's do it. All right, so it says the angle of elevation from Navy Pier to the top of Willis Tower is 64 degrees. Well, when you're drawing Willis Tower, you just need to draw a line here, okay? Don't do anything fancy. Just draw a nice vertical line. And you're drawing it, and by the way, it forms a right angle here. And this is 64 degrees. Okay, that's the angle of elevation, always from the horizontal line. You walk, or you travel 153 meters. So this distance right here is 153 meters. All right, and then the angle of elevation, so once you get to this point right here, then the angle of elevation changes to 82 degrees. And you can see it's steeper. Okay, and you can, people sometimes make a mistake and they put it in the wrong spot. Just think logically, as I go farther out, isn't the angle less, and as I get closer and closer and closer, it goes 82 degrees, and eventually you're looking straight up at it and it's 90 degrees. Okay, so make sure you're careful of where you put the numbers. But anyway, you find the angle of elevation to be 82 degrees. Find the height of the top of Willis Tower. So I'm going to label this as H for the height. And so this is how you do the problem. It's really not that difficult, but just it takes a little bit more, it's more algebra than anything. So if I call this distance here X, okay, what I'm going to do is I'm going to use tangent to figure really this problem out. And the reason I'm using tangent is because I don't really care about the hypotenuse. Those hypotenuse, or hypotenusi, I guess, they don't really mean anything to me. Okay, completely irrelevant. I'm just going to use tangent, which basically uses opposite and adjacent. So watch what I'm going to do here. I'm going to do tangent of 64 degrees equals opposite over adjacent, and the adjacent, the whole side, is x plus 153. Okay, that's one equation. Oh, did I say one equation? That means there are two. Oh, that might be a system. Oh, geez, I gave it away. What the heck? Okay, and the next equation is going to be tangent of 82 degrees equals same thing, opposite over adjacent. Okay? So what I'm going to do with each of these now is I'm going to cross multiply. So I get h equals, I'm going to put this in parentheses, x plus 153 tangent 64. And this one, if I cross multiply, I get h equals x tangent of 82 degrees. So these are my two equations I'm going to deal with. Well, of course, if you remember from your algebra days, it's just use substitution now. I can substitute one of the h's in for the other, and I really get x plus 153 tangent of 64 equals x tangent of 82 degrees. Okay? And I'm solving for x. Okay, again, it's kind of like it's a big old algebra problem. You want to distribute this, the 153 and the x to the tangent 64, so I get x tangent of 64 plus 153 tangent of 64 equals x tangent of 82. Okay, now I'm going to move all the x's over, so I'm going to actually subtract this to the other side. So I'm going to say it's x tangent of 82, right, which is this guy right here, minus, when I subtract that over, minus x tangent of 64, and that equals this left over on that side, so 153 tangent of 64. And then I'm going to factor an x out of here, so x times, I have tangent of 82 minus tangent of 64 equals 153 tangent of 64. Then I'm going to divide both sides by tangent of 82 minus tangent of 64, tangent 82 minus tangent of 64. Now here's the deal, math fans. I'm going to make a big deal out of this. In order for this problem to work out correctly, you got to put parentheses in the bottom. If you do not put parentheses in the bottom, you just do 153 tangent 64 divided by tangent of 82 minus tangent 64, it's going to divide it by tangent of 82, and then it's going to subtract tangent 64 from the whole thing. Okay, so you got to put that in parentheses in your calculator. Try it out, play with it, just see what happens. But basically, if you put it in your calculator correctly, you should get x is equal to 61.933, and it just kind of keeps going here. Okay, and then this is not the answer, and this is a mistake that a lot of kids make, is they put that on the answer blank. That's x. X is this here. I mean, that's nice that you figured out x, but that's not what I'm looking for. You're going to lose 1 point because you didn't figure out h. And so to figure out h, which one are you going to plug it back into? Well, why don't you just plug it back into the easiest one? Isn't this the easiest one to plug it into? H equals x tangent of 82. So there it is. H equals x 61.933. By the way, don't round. This is stored in your calculator. Tangent of 82 degrees. Okay, so you multiply all that out, and we wind up getting h equals 440.7 meters. So there's your answer, 440.7 meters. Okay, make sure you know how to do that problem. Like I said, it's on the quiz, on the test, in the homework tonight, in the homework tomorrow night. Make sure you know how to do it. All right, so these are all the different bearing types of application problems. And hopefully you guys are good to go with this, and you know what you're doing with everything, all right? That's it, math fans. Have an outstanding day. Adios. Goodbye.